In this video, I'm going to present about salinity of oceans. It is the total amount of solid materials in grams contained in 1 kilogram of seawater, which is called as salinity, and it is expressed as part per thousand. So it is expressed as part per thousand, and salinity affects the other physical properties of the oceans like temperature, density, and freezing point, boiling point, etc. If salinity of seawater is higher, it freezes slowly. For example, normal or fresh water freezes at 32 degree Fahrenheit. If the seawater freezes at 28.4 degree Fahrenheit, and the boiling point also high. So normally fresh water boils at 100 degrees Celsius at sea level, whereas if salinity is more, then it will be having high elevated boiling point. Evaporation is low because boiling point also is high. The evaporation also decreases, and because of the constituents or the whatever materials which are there in the saline water and saline materials, so because of the density increases in the saline water or seawater. Sources and composition of seawater. Sources, so mainly salt brought by the rivers and volcanic ashes are the main sources of salt in the seawater. The composition of salt water or seawater is sodium chloride, which is about 77.8%, magnesium chloride, which is about 10.9%, magnesium sulfate 4.7%, calcium sulfate 3.6%, potassium sulfate, which is 2.5%, calcium carbonate, which is 0.3%. Whereas here in the seawater, sodium chloride is the major constituent, but in the river water, it is calcium carbonate, which is the major constituent of salt. Other elements like silver, gold, radium, etc. also occur in minute proportion. Controlling factors of salinity. Range of variation in the distribution of salinity within the ocean occurs due to several factors like evaporation, precipitation, influx of river water, atmospheric pressure and wind direction, circulation of water, oceanic water, etc. Evaporation. Suppose if evaporation is more and the salinity also is going to be more, because both have direct positive relationship. In tropics, because of the low humidity, drier is there, and because of that salinity is more. But whereas in equator, it receives more precipitation, whereas high humidity is there and salinity also is less in this region. Salinity is 34.68 per thousand at 5 degree north latitude, whereas in the tropical region, if you see at 20 degree north, the salinity is increased slightly by 30. It is about 37 per thousand. Precipitation also affects the salinity of the ocean because it is inversely related to salinity. If precipitation is more, salinity will decrease. And in the equatorial region, precipitation is high, because of that it records low salinity, and temperate region supplied by meltwater, and because of that it has a low salinity. Whereas in the tropic region, precipitation is poor, so it has higher salinity. Influx of river water. In the enclosed seas, which are more affected by the influx of river water, if the water input is more than the evaporation, then there will be low salinity. Example, Gulf of Bothnia. If water input is less than the evaporation, and it will have a higher salinity. Example, Mediterranean Sea. At river mouth also, salinity is less in the larger seas because it receives more water input, and seasonal variation also is observed in those rivers or in the enclosed sea regions. Atmospheric pressure and wind direction. Subtropical high pressure belts like anticyclonic conditions. Because of that, there will be a stable air in those regions, and high temperature increases the salinity of oceans. Winds also helps in redistribution of salt in the oceans. Example, trade winds drive away saline water from the western coast of continents and pile them near the eastern coast. So if the saline water is driven, suppose in this region saline water is driven towards the other region, so here the salinity will decrease, whereas here because of the piling of the water, salinity will increase. The Gulf of Mexico salinity is 36. For example, Gulf of Mexico, it ranges between 36 per thousand to 37 per thousand because of the piling of water from one region to other region. Circulation of oceanic water affects the spatial distribution of salinity by mixing sea waters. Oceanic warm and cold currents play a major role in the circulation of oceanic water. Horizontal distribution of salinity. So first one is latitudinal distribution. Salinity decreases from equator towards the poles. Highest salinity is recorded at tropics. At equatorial zone, salinity is 35 per thousand, which is relatively low, whereas in tropical region, which is 20 to 30 degree north, which is 36 per thousand, and 10 to 30 degrees south, which is 35 per thousand. So in this region, maximum salinity is recorded, whereas in the temperate region, which receives here precipitation is poor, but at the same time here which receives more meltwater. So in the 40 to 60 degree north region, which the salinity is 31 per thousand. In the northern hemisphere, which is 31 per thousand, whereas in the southern hemisphere, which is 33 per thousand. And polar zone, here minimum salinity is recorded, and average salinity in the northern hemisphere 34 per thousand, and the southern hemisphere, which is 35 per thousand. Horizontal distribution is affected by factors like rainfall, rivers, river water input, meltwater input, and from the polar region, and ocean currents, temperature, and winds affect the horizontal distribution of salinity. So in this, here we can see here, so in this region, this is the equatorial region. In the equatorial region, salinity is little less, whereas in the tropical region salinity is more, whereas the input of river water, so in this coastal region we can see salinity is little less, whereas in the temperate region salinity is less further, but in the polar region it further decreases, salinity further decreases in both the hemispheres. Salinity distribution of oceans, like the Pacific Ocean has salinity differences of Pacific Ocean is in wide range due to its shape and larger areal extent, whereas near equator the salinity is about 34.5 per thousand, and between 15 to 20 latitudes high salinity is recorded, which is 35 per thousand in the northern latitude. In the northern hemisphere, in the southern hemisphere it is 36 per thousand in higher latitude, and in the higher latitudes it further decreases in the Pacific Ocean, whereas the Atlantic Ocean average salinity is 35.67 per thousand, and maximum salinity is recorded in tropics, which is 37.7 per thousand. In the enclosed sea regions, the salinity varies depending upon the amount of water input is there, because depending upon that and the temperature it varies. The Indian Ocean average salinity is 35 per thousand, and it partially enclosed seas record higher salinity ranging between 37 to 41 per thousand. Inland seas and lakes have a different salinity variation. Salinity is controlled by the rate of evaporation, temperature, influx of river water, and presence or absence of outlets. For example, Caspian Sea records low salinity in the northern part, which is 14 per thousand, due to influx of water brought by rivers like Volga, Ural, but in the southern part, the salinity is reduces to 170. Salinity in the southern part, salinity is increases to 170 per thousand, whereas very high salinity is found in Great Salt Lake, which is in USA, and which is 220 per thousand. In the Red Sea, which is 240 per thousand. Lake Van, which is in Turkey, which records a higher salinity like 330 per thousand. Even Dead Sea also records a higher salinity, which is more than 230 per thousand. Regional distribution of salinity. It is described in two ways: distribution of salinity in individual oceans, we have discussed already, and distribution of salinity of all oceans. Whereas Jenkins' classification of oceans on the basis of salinity, so he classified into three different types. So seas having salinity above normal, which is above 36 per thousand. For example, Red Sea, Persian Gulf, Mediterranean Sea. These are some of the seas are partially enclosed, and these regions salinity is normal. Here influx of water also is poor, and the temperature influx of water is less, but the temperature is high. So these seas have more salinity, which is about 36 per thousand. Seas having normal salinity, which is averagely about 35 per thousand. And example, the Caribbean Sea, Gulf of Mexico, Gulf of California, etc. Seas having salinity below normal, so which is less than 35 per thousand. So this can be further divided into slightly less salinity or much less salinity. Slightly less salinity, for example, Arctic Ocean, Andaman Sea, Bering Sea, Japan Sea, China Sea, North Sea, English Channel have, and they have slightly less salinity, but There are some seas which has much less salinity, which is about 15 per thousand. For example, Baltic Sea, which receives more fresh water, and Hudson Bay, which receives more fresh water. So because of that, so these seas have much less salinity. Vertical distribution of salinity. So there is no definite trend because it increases and decreases with increasing depth. And the characteristics of vertical distribution of salinity are: in high latitude, salinity at a depth, it's a positive relationship. So salinity increases. If salinity increases, density also is going to increase, because both have positive relationship. Density also higher depth. In mid latitudes up to 200 fathoms, salinity increases with depth. Beyond that, it decreases. At equator, surface low salinity will be there because of the higher precipitation. In the subsurface region, it increases, salinity increases, and the depth it decreases again. Maximum salinity is found in the surface layer. Minimum salinity is found in the bottom layer. Transition layer, which separates the maximum and minimum salinity layers. Halocline layer, which is also called, in this region, rapid change of salinity occurs. For example, decrease in salinity with increasing depth in low latitudes, whereas in the increase in salinity with increasing depth in high latitudes occurs, which is also called halocline layer, because here it is a transition zone where the salinity rapidly changes. So that's why this layer is called halocline layer. Whereas in this, we can see that in lower latitudes it is different and the higher latitudes it is different.